I'm Ramki Krishnan, leading innovation in SDN NFV, and also very active in various SDOs, IETF, ATIS, and HCNFV, and in open source projects, especially Open Daylight. So, what I want to present today is kind of the direction of interesting targeted use cases for SDN and NFV. And I was chatting with Ethan yesterday, great chat, and then his takeaway was, hey, we need to have these good use cases where we can generate money and then revenue, and then that helps us go on to our bigger vision, broader vision. So what I'm going to talk about is specifically some novel ideas around Ddos mitigation using SDN NFV analytics. So if you look at Ddos mitigation today, the mega trends, the high bandwidth volumetric infrastructure attacks, especially layer 3-4, are on the increase, approximately 30% 2013, whereas the layer 7, I mean, when you say DDoS, people always associate with the full package, and especially layer 7, that's really not on the increase. And the average DDoS attack sizes have increased above, order of hundreds of gigabits, and you may know very well about the NTP reflection attack and Cloudflare CDN. And if you look at the market opportunity, we see around north of 1 billion by 2017 at a 25% CAGR from Infinitics. And the market segments we see a very strong opportunities are ISPs, internet exchanges, multi-tenant cloud data centers, and higher education. And so the way we see the use case is very interesting in the sense, especially the ISPs and internet exchanges have a huge opportunity in filtering your layer 2, 3, 4 type NTP reflection type, these type of attack traffics in real time, and preventing any overwhelming of the customer network, which is typically the enterprise, right? And essentially what happens today is you have these DDoS attacks typically taking out the entire customer data center, and you have these expensive Arbor appliances in the enterprise data center trying to address this problem. It's kind of a full package, layer 2 to 7, and then what happens is, hey, it detects the attack and also sends it for remote scrubbing to other data centers. But since it's a club layer 2.7 package, it comes at a huge cost, right? And what you're trying to do is essentially split the problem into layer 2.4 and layer 7, where through innovation we can address the layer 2.4 attacks, which are indeed growing in volume. And with this, essentially, we see a huge revenue opportunity for ISPs and internet exchanges to offer a differentiated DDoS mitigation service to their enterprise customers. And a quick comparative analysis, we went through especially the DDoS appliances. If you look at Arbor, Radware, they're great, and the best way to view them is they're cost prohibitive, but they're really useful for layer 7 attacks, right? Kind of stateful inspection and all that. So that's exactly their sweet spot, where the problem you should use them to solve, not look at these layer 2-4 volumetric type of attacks. And we're all very familiar with NetFlow. So here what is interesting is NetFlow, as it stands today, learns all the flows in the network: large, small, long-lived, short-lived. I mean, fundamentally these leads to the following issues. One is the flow cache thrashing. You're busy learning these small flows which are fast vanishing, right? And your flow cache runs out. And also, because you're busy learning all these fast vanishing flows, your CPU utilization goes high, spikes up. And also, additionally, the active timeout for flow export is at least 1 minute. That means you learn a flow, it takes at least a minute to export. So that means it's not meant for anything real time, great for capacity planning. And now, there have been many approaches, other approaches proposed, hey, why not use OpenFlow? You opened up the infrastructure, OpenFlow counters. But gee, here the problem is this leads to two fundamental problems. One is the scalability, because you need to pre-install the routes. The other is you're doing counter polling. You're just polling all these, busy polling all these counters to detect any issues. So in essence, the way I see it is it's useful as a flexible layer 2, 3, 4 ACL, and that's it. And so now moving on to kind of flow categorization. So we talked a lot about this control theory, and this is a nice matrix of different types of flows. Short-lived large flows, then long-lived large flows, short-lived small flows, and long-lived small. So you all know this very well. And the very interesting part is just focusing on the long-lived large flows, where these flows at least persist for the order of tens of seconds in the network, and a bandwidth is proportional to somewhat link bandwidth, maybe at least 10% of the link bandwidth. So if it's 10 gig, you're looking at least 1 gig. And by just focusing on these, we lead to kind of a very interesting control theory implication. So essentially, such flows are observable, controllable, and also scalable from a table perspective, leading to a very stable control system, whatever we are trying to do with it. And this is key to real-time SDN NFV analytics as we see more. And this is all captured in the work in IETF, which is happening. It's very active, large flow use case supported by Verizon and Telefonica. And now let's see how the DDoS mitigation can be solved in a real-time SDN. As we saw, DDoS attacks, especially the volumetric attacks, qualify as a long-lived large flow, right? Order of tens of seconds and tons of bandwidth, order of gigabits per second. So here, the sequence of events is the first is the number one, flood attack overloads the customer port, and the attack, which is mapped to long-lived large flows, is detected by Inmon S-flow RT, right? Kind of this is a whole system, and it characterizes the flows based on source IP, destination IP protocols, and S-flow samples are being continuously exported to Inmon S-flow RT, kind of pushed, and S-flow RT replaces the classic S-flow, which is more of just for capacity planning, into a real-time application which can detect large flows in real time. And the third step is using a REST API. These detected large flows or the DDoS attacks are conveyed to the Ddos Mitigation SDN application, which kind of maps the attack to the relevant QoS action, drop or rate limit, right? And pushes that that action, the rule with the action, using REST API to the SDN controller, and the SDN controller maps it into an open flow rule. Right now the implementations are based on open flow, but in the future we see the IETF I2RS kind of the hybrid model coming in to switches. And here the last step is essentially the open flow rules are programmed in the switches and routers to remark traffic and protect the link, remark or drop or rate limit, all the QoS actions. And here the most interesting part is, as we saw, looking at long-lived large flows leads to a very stable control system, and where open flow gives the right performance also additionally. And here the very important components are, one is the Brocade hybrid open flow. Why hybrid open flow is very important is we are only making specific QoS actions on certain flows. We are not changing the existing forwarding behavior. The existing forwarding is picked up from traditional ways. That means such a solution can be dropped into an existing customer network without absolutely any disruption. That is the key point about the hybrid open flow. And Brocade, especially the MLX, has a superior hybrid open flow implementation where we can map different incoming VLANs to open flow or non-open flow pipeline, and we can dynamically switch from the open flow pipeline to the forwarding pipeline, and that's exactly what happens here. And here with this, I mean, since SFlow is based on sampling and extremely lightweight, we see a huge market opportunity in all the market segments: ISPs, internet exchanges, multi-tenant cloud data centers, and all these being able to offer differentiated services to their customers, and also in higher education, where traffic is really dynamic with protecting their internal network. So, and also point to notice this is, as I discussed before, this is progressing very well in IETF with support from Verizon and Telefonica, and also essentially how we are envisioning configuration is through a customer portal, where essentially you configure various parameters for such an application. What will be the minimum size of the large flow and all those parameters. So now the next interesting aspect is we talked about real-time SDN and solving some interesting problems, and what we also see is very interesting ways through which NFV can complement SDN. So the same idea, essentially we talked about an external control loop where we solve this interesting Ddos mitigation problem, where you have SFlow RT and SDN control and SDN application. So now what is really happening is all that an external control loop is collapsed nicely into Brocade Vieta, small loop. All those set of actions or detection, mitigation, everything is happening inside the virtual router. And so then you may ask the question, why not use custom hardware for such an application? The key is custom hardware is not flexible, not a flexible innovation platform. And DDoS and these type of attacks, these would change, be new type of attacks, and you need the flexibility to handle different types of attacks. That's where NFV gives essentially the flexibility and also the performance, like James was talking about before. And here what is happening is the same set of steps, but in steps 2 and 3, essentially you have the virtual router detects the long-lived large flows, right? But based on observing every packet in line, not sample data, right? Before we talked about sample data, you were sampling 1 and 2K or something like that. But since this, you're looking at each and every packet, you can make much faster decisions, order of magnitude faster than sampling technologies. And here, unlike NetFlow, our position is not to learn each and every flow and keep trashing the cache. We have smart pre-filters which will focus only on long-lived large flows and have few small positives will be purged. So essentially the key is just focus on the long-lived large flows, ignore the other flows, and learn them super fast. Yeah, of course. Yeah. So that is the key here. And and also notably, essentially you detect the long-lived large flows, and you have local policies for assigning the right QoS actions, right? And you insert PBR rules right into data part, all happening in a single control loop. And of course, here in this case, if desired, the flows can be conveyed to upstream routers using BGP flow spec. In fact, we like even the other approach even better, where you can use IPFix with extensions or REST API to convey these attack flows to an external SDN application, which uses hybrid open flow to program in other upstream routers. And here, notably, we are reading the effort in NFV in terms of a proof of concept, which just got accepted a couple of days back with support from AT&T and Telefonica. And now so I will show a quick demo of the SFlow RT with a controller OpenDaylight and MLXE.
So part of the real value is here too, I think it's going to get replicated elsewhere. That, you know, there's lots of great tools out there for looking into deep networks for different reasons. There's lots of great tools out there for forensics, analysis, and so forth, but most of them are very expensive and they're very specific, and you can't have them everywhere you want them all the time. And so the idea here is also a bigger idea of applying a wider net that can catch, that then can take a flow and redirect it somewhere for deeper analysis. That may even result in failing back, right? But the idea is now you have the wider net and you have the specific net. And so we think that aspect of usage model for this is going to be very powerful for all these kind of very specific scalpel-like tools that you want everywhere, but you can't really have everywhere today.
So here we have a setup where essentially you have, let me point here, I think it's better. So you have the attack traffic, which is kind of, you know, this is a continuously running demo which you're planning to show in ONS. So the red line is the attack traffic at 1.8 gig, 20 seconds on, 20 seconds off, right? And we have the green, the good traffic, this baseline around 0.8 gig, always there. And so then the attack traffic is NTP reflection traffic with source port 123, you know, attacking some server in the customer data center, and UDP protocol. And here what is happening is continuously, as we can see, the attack persists for 20 seconds, and then here it is actually instantaneously detected by SFlow RT in the order of seconds and mitigated, right? And so as we saw in this case, the cycle is SFlow samples going continuously, then INMO and SFlow RT detecting a large flow, signaling to the SDN application, which programs a drop entry in the MLX through a hybrid open flow to mitigate the attack. And here I will show you. So this is the drop entry installed in MLX, and you can see the counters continuously incrementing. 496, and also we can see this in open daylight. Oh yeah, I think the flow got removed because the attack. So let's wait for a second. I think we should be able to see it now. Not yet. Next cycle. Okay. Okay. Yeah.
Boom.
So the destination IP of the victim, and you can see the source port is 123, UDP protocol 17, also in open daylight. That's the flow path. And all this is happening from this continuously in the order of a couple of seconds. So each time they attack, this is the attack, and this is exactly how it's detected and mitigated right away. And also notably, this such a hybrid open flow implementation is extremely robust. So one of the things that happens is, even when you're adding a drop entry and dropping the traffic, you are essentially sampling the traffic still, so that you can find out if the flow falls below a certain bandwidth, and you can remove the entry automatically. So it's self-healing. And also the other aspect of a hybrid open flow is that it's completely robust, in the sense it's the forwarding. If you lose communication to the controller, you will automatically purge the entries, the flow entries which are added by the controller. So then forwarding happens as usual. It's completely decoupled. I think the separation between the forwarding and other type of actions is really key to SDN success, in current deployments, where smoothly making them work on deployments which exist today. And this is a.
I was going to say, so with my security guy hat on, and as someone who bird dogged and whack-a-mole NTP reflection attacks for a week. I think this significantly changes from a campus and service provider perspective the way that you can, like you said, it's a broad net, right? And so it allows for this broad, this broad sword of a tool, and that gives the security guys what they're always asking for, right? They want visibility at every layer of every part of the network. This makes that easy.
Thank you. Thank you.
Which I think is something that no one's ever really done before, and more importantly, it makes it much more cost effective than putting optical taps and bro nodes or SourceFire nodes in like every one of your
aspects of this we have to realize is that moving forward, maybe not tomorrow, we have to get to a point where I can take a trusted person, mark them as untrusted for a period of time without them knowing, okay, still record what they do, and then later decide they're fine and put them back into the flow, re-merge everything they've done, and they don't know the difference, because if they know that they were quarantined for a period, that violates their trust model, and that's going to happen. You're going to get outliers, you're going to get weird things that are going to happen. Good people are going to look bad, bad people are going to look good, but this has to be a part of the flow. And so this ability to tag someone, move them somewhere, look deeper, and then hopefully 99% of the time, kick them back. Because 99% of the time, it's probably nothing nefarious. It's that 1% you really want, right? And so this is a basic battlefield tactic of looking at the bigger scope, and if it's someone you really want to get into, you invite them into that alley that happens to have the most firepower.
And also the other thing I'd really like to add is, in this case, where we see it is especially the NTP reflection type, the layer 2-4 attacks are really growing.
Yes. And
throwing an arbor at them is just not the right way to solve the problem.
Yeah.
Right? I mean, basically we divide and conquer, and and innovate.
Because I mean, as bandwidth gets cheaper and as interfaces increase, that's not going to make this problem any better.
Yeah.
No, it's going to make it harder.
Yeah.
Exactly.
Right? Because now you have a bit cannon at your desktop.
Exactly.
And what this says to me is that for a very small entry fee, the cost of OpenFlow hardware controller and the time to set it up, you've got a network-wide NAC that is not a bump in the wire that can die and cause an outage because it's part of your existing infrastructure.
Exactly.
And let's be honest, we
you run
really,
at a service provider level too.
Exactly. We really expect the huge, cool use case of this to be the thing that you guys come up with after you get it, right? So.
And also, our takeaways so far from what I've seen talking to ISPs, we always see NFV adding additional value, like it depicted, faster detection, more flexibility. But of course, NFV is not for all market segments. For example, doesn't apply to internet exchanges.
And I think we're done.
That pretty much wraps it up right at 10.